Yes, we are live. Woo! Just adjusting a few things. Got to get all my screens all ready to go. Wait, what the heck? That's weird. Okay. All right, we're all set. So how are we doing on this fine Wednesday morning? Ugh. It's weird. I get like 8 or 9 hours of sleep, but I feel like I don't get 8 or 9 hours of sleep. It's the weirdest feeling in the world. All right, so today we're going to go over sections G, H, and I. Just adjusting that a little bit. So in section G, it's all about exponents and how to manipulate them. So we want to be able to simplify it to where there are only positive exponents. So if I were to do, let's say, number 2, I want to separate this so I get 7, and then it's 5 over x plus 4. And then the negative 1 is on top. Now, if you notice, it says x plus 4 to the negative third on the bottom. So right here, it's x plus 4 to the negative third. Now, on that negative third, whenever we have a negative exponent, we can move it over the divisor to then make it positive. So I actually want to take that and move that to the top. So I get negative 1 times, and then it'll be x plus 4 to the third, because when you move it, the exponent becomes positive, or it just switches its sign. So because it was negative, it's now positive. And then there's nothing left in the bottom, so we'll say over 1. And then on this next one, because it says x plus 4 to the negative 2, I can then move that to the bottom. So I get 1 over negative 2 times x plus 4 squared. So now I want to try and clean this up and see, does anything else cancel out? Well, I have 1, 2, 3 x plus 4s on the bottom. I have 2 here, and then I have another one here, so that gives me 3. Well, that's going to cancel with the 3x plus 4s I have on top. So I'm left with 7 times 5 over 1 times negative 1 over 1 times 1 over negative 2. So 5 times 7 is 35, times negative 1 is negative 35. And then on the bottom I have negative 2, so that's going to be 35 over 2. Any comments or questions on that? Now for number 3, what we're going to have to do is we're going to have to rewrite it. So sometimes things can simplify and then we can reduce. Now we can't really reduce when it's in a square root form. It's awkward, it's strange, it's weird. So we want to try and convert it into an exponential format, and when we convert it into an exponential format, then things can reduce. So I have this square root of 9x minus 81 over, and then I have the fifth root of x minus 9 to the fourth. So the first thing that I notice is with this 9x minus 81, I know the 9, there's a common between both of those, so I could factor out that 9. I'm only going to focus on the top for now. And now this is the square root of 9. Well, I know what the square root of 9 is. It's 3. So this is going to give me 3 square root of x minus 9, and then over the 5th root of x minus 9 to the 4th. So it's a good thing that both of these are x minus 9s. That tells me somehow things are going to cancel out. Because if you ever have something that's the same on the top and on the bottom, things will reduce in some fashion. Now, because it's a root, we don't know any root definitions that help us cancel things. But we do know exponents. If we're multiplying exponents of the same base, you add the powers. If you're going to, if you're dividing with exponents of the same base, you subtract the powers. And so we're going to use that same thing here. So I'm going to rewrite this as 3 to the x minus 9 to the 1/2 over, and this would be x minus 9 to the 4/5. So that means that the bases are the same, subtract the exponents. So I want to know what 1/2 minus 4/5 is. So I have to find the common denominator. Five minus 8 is -3, and that's over 10. So this is going to give me 3 times x minus 9 to the -3/10. In the instruction, it says only positive exponents, so that means I'm going to have to move that to the denominator. And so that's going to be our result. Any questions with that one? Okay. So let's move on to H. So H are what we call complex fractions, meaning that we have fractions within fractions. So essentially the goal is to try and make it into 2 fractions. That's all we want to do. Because if I look at number 1, I have 1, 2, 3, 4 fractions. I don't know how 4 fractions divide out. But if I can do 2 fractions would just end up looking like this. Fraction divided by fraction. And we know how to do that. If it was 1 over 2 divided by 3 over 4, we know how to do that. We know how to simplify when it looks like that. But I want to try and get it to look like that. That's kind of like the goal here. So what we need to do is we need to combine our fractions together as much as possible. So for example, I have 2 over x minus 3 over x squared all over x squared over 9 plus 3 over 2. So I have 2 fractions. I want to combine that into 1 fraction. So this needs a common denominator, 9 over 9. Now if I do that, I'm now going to have 2x minus 3 over x squared. So because the denominators are the same, when you add or subtract, You just have the denominator. And then this is x times 2, so that's 2x, and then I have minus 3, so 2x minus 3. Now we should do the same thing to the bottom. So between 9 and 2, the common denominator is 18. So this needs a 9 over 9, and this needs a 2 over 2. So it's going to be over 2x squared plus 27 over 18. So even though it still looks like there's a lot going on, essentially I have combined it into two fractions. I have one fraction right here, and my second fraction is right here. So I have combined those into two fractions. And so I can rewrite it like that. I could say 2x minus 3 over x squared divided by 2x squared plus 27 over 18. Now, if you remember, whenever we're dividing with fractions, you have to change it into multiplication, and you're going to flip the second fraction. Now we have to see, are there any factors that reduce? Now, there is nothing in common with the 2x minus 3. There's nothing in common with the 2x squared plus 27, like I can't factor out a 2. So as it stands right now, nothing reduces. So I could just write it as 18 times 2x minus 3 over x squared times 2x squared plus 27. And that's my answer. Any comments or questions on that? So like I said, the goal, just to combine it into two fractions. Once it's just two fractions, it's this, which we've done a lot of. We've seen that in math for at least 3 years. Any questions on the one that I just did? So I want to give you guys kind of like the opportunity to work through them. Number 2. Yeah, let's go through that. So on number 2, and then I'll go ahead and because on number 4 and number 5, you just have to set it up. So we'll get to that point where we set it up. So on number 2, we have 5 over 6 plus 2m plus 3 over 6m all over, and then 5 over 36 minus 5 over 25. Okay, so we have to combine these into one fraction. So between 6m and 6m and 6, this needs an m for them to be the same denominator. Between 36 and 25, there is nothing in common, so this needs a 36 over 36, and this needs a 25 over 25. Some big numbers there, but that's okay. So now let's rewrite what we have. So this is going to give me 5m plus 2m plus 3 over 6m. So I combine that. If you want to, you can just rewrite this instead of saying 5m plus 2m. You can just write that as 7m. And then over, so now we're going to have to get out our calculator, mainly because doing things in our head can mess us up. So 5 times 25, that one's easy. So we're going to get 125 minus then 36 times 5. So that's going to be 180 over now 25 times 36. So that's going to be 900. Now 125 minus 180, that's going to be negative 55. So I could just rewrite that. And so now I have my two fractions. I have this fraction on top and this fraction on the bottom. So now we can write it out. 7m plus 3 over 6m divided by negative 55 over 900. Then because it says divide, we're going to flip and make that times. Now we want to see, are there any factors that reduce? So between 6 and 900, I believe 900 is divisible by 6. So you get 150. So I'm just going to kind of combine those together. So you're going to get 7m plus 3 times 150 over negative 55m. Now there is also a 5 in common between the 150 and the 55. If I divide that by 5, you get 11. If you divide that by 5, you're going to get 30. And so I hope my face doesn't block it, but you're going to get 30 times 7m plus 3 over negative 11m. Any questions on that one? So just know, no matter what it looks like, you're always doing the same thing. Sometimes it can get a little bit more complicated in how it looks, but the goal is still, how do we combine these together? Now let me give you an example. Let's look at number 5. So on number 5, we have x to the negative third minus 1 over x to the negative 2 minus 1. Okay, well, at first, we should look at those negative exponents and be like, negative exponents, I don't like those. Let's get rid of them. So if we imagine that that is over 1, and then that is over 1, we need to first rewrite that like so. And then we can view this minus 1 as negative 1 over 1, so that we have a numerator and a denominator. And then now we can go about finding the common denominator. So then this needs an x cubed over x cubed. This needs an x squared over an x squared. ... You can go through and start simplifying it that way. And then so the same thing goes for number 4. We have that a minus 2 to the negative 1. You're going to want to get rid of that first by making it a positive exponent. So you're going to move that a minus 2 to the top, and then you can find the common denominator between those things. Any other questions on those? Okay. So let's move on to section I. Finding the domain. So the domain restrictions, there were 3 that we talked about. First, can't divide by 0. Second, can't have a negative inside of a square root. And then third, unfortunately, we haven't talked about it because of the time crunch and us doing things at home. But you can't have a negative or a 0 inside of a logarithm. So, for example, number 8 is a log. I can't have a 0 or a negative inside of it. So it's all about how we set it up. So let's look at a few of these. And number 3 is also a log. So like on number 1, it's not a log. I'm not dividing by x. Nothing's in a square root. So therefore, there's no domain restriction. It's all real numbers. So number 1, my interval is going to be negative infinity to positive infinity. But on number 2, I have y equals x plus 3 over x minus 2. I have this x in the denominator. I can't have an x in the denominator. If I divide by 0 somehow, that's a domain restriction. It's undefined. So I'm going to find where it's going to give me a 0. So I'm going to say x minus 2 equals 0. Add 2 to both sides. X equals 2. So if I plug in 2, I get 5 over 0. So therefore, this is my restriction. So it cannot be that. So on my number line, I have 2. It can't be that. I did not say or mention it can't be anything else. So it'll be from negative infinity to 2, union from 2 to infinity. Let's look at number 5. So I have y equals the square root of 2x plus 1 over x. So there's 2 things. Square root, can't divide by 0. So I have to think of those as separate, and then what I'm going to do is I'm going to take those 2 restrictions and I'm going to overlap them, which is basically finding the intersection of the 2. So the first thing, that 2x plus 1 that's inside of the square root, I never want that negative. It can be 0, it can be positive, but it can't be negative. So that's why we say greater than or equal to 0. Because numbers that are greater than or equal to 0 are positive numbers and 0. So we're going to solve that. So I get x is greater than or equal to 1/2. So that's my first layer of domain. So if I say this is 0, that's going to be negative 1/2. It can equal it, and x is greater than that. So I'm going to shade all of that. So now I need to find the next piece. So the next piece is I have this x in the denominator, and we can't divide by 0. So you take it, and you set it equal to 0. Well, x is already by itself. That's kind of easy. So I just know that x cannot equal that 0, because if I plug in 0, I get the square root of square root of 1, which is 1 over 0. That's undefined. Can't have that. So then that restriction is going to be at 0. It's an open circle. But for that specific restriction, I didn't say anything else is restricted. So technically everything else is shaded. So now I need to find where is there shading on both the top and the bottom at the same time. We call that the intersection. So from here, from that negative 1/2, and then because there's an open circle here, they're not overlapping there. So I'm going to get negative 1/2 to 0. But then all of this is overlapping. So therefore, from 0 to infinity, it's going to be overlapping. Any questions on that one? All right, let's try a log. So let's try number 3. So for a log, even though unfortunately we did not have the time to go over it, it's very similar to the inequality one, or the square root. But basically all we need to do is we need to say it cannot be negative inside of our log. And it cannot be 0 inside of our log. So only positive numbers. So the way that we algebraically express that is by saying values that are greater than 0. Because values that are greater than 0 are positive numbers. So you take whatever's inside the log and you say greater than 0. So then you're going to add 4. 3x is greater than 4. Divide by 3. X is greater than 4/3. And that's our result. Now for the interval notation part, we would have 4/3. It's an open circle. It's greater than that. So that's going to be 4/3 to infinity. Ugh, a bajillion emails. Always emails. So busy. Okay, so that's pretty much covers sections G, H, and I. If you guys do have questions on them, just post it into Discord chat, and I'm more than happy to answer them. Before we go, are there any last questions? Cool. All right. Well, thanks, guys. I really appreciate you guys showing up, and I hope you are healthy. I hope we are able to get outside and get some sun. It's very necessary. And we're almost done. I think, what is it, 1 more week from tomorrow? And then summer begins. So, thanks for showing up, and I'll see you guys later.